Okay, so question 9. Change the subject. Make X. And a good way of doing this is to have a think about how this formula was started in the first place, how it was created. If we take X, the start, the first thing that happened to X was that it was square rooted. And then the next thing to happen to X after that was it was -5. And then out came Y. To go back the other way, we're going to put Y in and use our inverses. So Y goes in, we're going to do the opposite. We're going to add 5. So we use our inverses in reverse order. You go through, we're going to do the opposite of square rooting, which is actually to square it. Okay, little square button. Out will come your X, so this will equal X. So let's do that. Let's put Y in, and we're going to add 5 to it. And then we're going to square it. We've got to square the whole thing, though. We've got to do the same thing to the thing's already there. So now we put this in brackets, and we square the whole thing. And that is what X equals. Okay, we've left X on its own. So we've stripped this away. We've got rid of the 5 by adding 5. We've got rid of that. We do that to the Y, to both sides. And then we get rid of this square root by squaring it instead. That's left the X on its own. Okay, and this will have had added 5 and then square the whole thing. So really important, whatever's on this side, when we do the next operation, we do to the whole side. If it had to be, let's say, divide by 3 was the end thing, then the whole thing would be over 3, okay? Or you could put brackets and put divide by 3 at the end, but the whole thing has to happen at the end, okay? So the last thing happens to whatever's already there, okay? So change the subject, make X the subject, just move it around, strip it apart bit by bit, but think about how it was created in the first place. So quite a lot of algebra in this set of questions, but there always is, about 20% of the exam will be algebra. So it's good to get a few marks along the way if we possibly can. Solving this equation. So solve. When it says solve, it means it actually wants a value for X. It wants you to end up with either X equals or something equals X. So we're heading for getting our X on its own with a number value at the end. So this is a weird one, because we've got it's in various parts. It's actually quite a complicated one, so hopefully we won't get anything as difficult as this. But we need to, first of all, again, strip it away and get the X as one side. I've got 1X here, I've got 7X over here. So I am going to keep my X's on the left-hand side here. I can actually easily move this 5. I'm going to add the 5 to this side and add it to the other side as well. I'm doing the same thing to both sides. It's absolutely crucial with any rearranging you do the same thing to both sides, and you use inverses to unpick it. So the next one is going to read, I've not touched this 7x over 5 yet. I'm going to add 5, so that is going to get rid of that 5 there. Okay, I'm doing inverses. So add 5 to this side. I can even write it out if I need to. -6, add 5. So I've got X -6, add 5, leaves me with -1. On this side, I've still got 7x over 5. So now I'm going to get rid of this x. No, not actually. I'm going to get rid of this 5, because this dividing by 5 is actually stuck to this bit. I want to unglue it. So I'm going to times the whole side by 5 and this whole side by 5. Okay, that will get rid of my divide by 5, but this whole side must be multiplied out. So we're going to have, so we've got 7x over, we've just lost the 5, haven't we? Sorry. So we've just lost the divide by 5. I got rid of that. We're left with 7x on this side, and over this side, we're going to have 5x minus 5, because I've done x times 5, and I've done minus 1 times 5. The final step now is to move, well, penultimate step, to move this 5x. So I'm going to get rid of this 5x on this side. Okay, I'm going to take away 5x on this side. So that has got rid of it. I am now left with 2x on this side equals minus 5. Right, I want to know what x is though. So to get down to a single x, I need to do dividing by 2 on both sides. I'm balancing out the sides again, doing the same thing to both sides. And you can use your calculator for this if you need to, but I know minus 5 halved is minus 2.5. Don't forget you do have your calculator, so you can do the calculation on there if you need to. So your final answer is that. Okay, you could put that back in and actually check that both sides balance, but there is a check you could do if you wanted to. Okay, nth term. So for this, I like to use the idea of dyno. So the difference is always glued to the n, and then you go back to the 0 term. There are other ways of doing this, but this is one method that I quite like. So the first job is to find out what is the gap between these numbers, and you're going up to, and if you just write up to on each of them, you may get a mark for that even. It's always worth putting the arrows on so we know that you're talking about the direction. So look, there's our difference. Straight away, our difference is 2. The 2 must get stuck to the n, 2n. I then need to go back to the 0 term. Now, this is a very straightforward sequence here. This is term 1, term 2, term 3, term 4. This is when n equals 1, n equals 2, n equals 3, n equals 4. If I go back to the 0 term, okay, I would come backwards 2. I land on 0. So effectively, you're doing 2n plus 0. Now, we don't actually need that. It's actually just going to be 2n. But if it had landed on something other than 0, we would need to put it on there. Like if it had gone back to -1 or gone back to -7, you'd stick it on the end as your constant on the end. Okay, so whatever you land on. Also, other way, look at it. Okay, 2n, 2 times 1 is 2. It works. 2 times 2 is 4. It works. 2 times 3 is 6. It works. So there's nothing more to add on. But if you did that, checked it out, and it didn't get the number you wanted to land on, you would then add or subtract the number you needed to make your answer. And that has to be the same for all the numbers in the sequence. Okay. Okay, now this question here makes relies on some prior knowledge, and that is that any map scale is given in this format unless it says anything else. It's meaning a centimeters on this side and centimeters on this side. It also means that this side is your map, your model, your plan. Okay, the shrunk down version of it. Okay, this side is real life, the actual distance on the ground, the actual size of the object that's made in real life. Okay, so that's an assumption, 2 assumptions the question makes. Now, it's dealing now with what is the actual distance represented by 13 centimeters, but they want the answer in kilometers. So we've got 2 marks, 2 ways of getting some marks here. We need to use the scale, and we also need to use the conversion between centimeters and kilometers. Let's write it out again here so we've got a bit more space. Very careful to get the right number of zeros if you rewrite anything from your paper. Okay, so cm. So some students like to do the deal with the on the map, the scale thing first. Some like to get this into a nicer number to start with. So I'm going to do the conversion first. I'm going to put this into meters. I'm going to convert it to meters. I don't like jumping from centimeters straight to kilometers. So to go to meters, I'm going to divide by 100. That is like knocking off 2 zeros. So to get this into meters, it's 1 centimeter on my map equals 250 meters. Okay, it's still a centimeter. I'm literally doing a conversion, but they want it in kilometers. So you might want to do that bit at the end, but I'm going to do it here. How do I get from meters to kilometers where there are 1,000 meters in a kilometer? I'm going to divide by 1,000. But don't forget, again, you've got your calculator, so you don't need to worry about moving decimal points and stuff. You can just do 250 divide by 1,000. Get the right number of zeros in there. It's all relying on your knowledge. Press the SD button, 0.25. So 1 centimeter, okay, on the model is 0.25 kilometers. It's almost like a new scale you've got there now, but just built up from the original one. Final thing I want to do is actually find out 13 centimeters on the map. Okay, so I put 13 on my map side, and I'm going to use my new kilometer scale to get the answer. Now, from here to here, I have times by 13. So the golden rule of the length do the same to both sides, times by 13. You might have wanted to use the link going that way, times 0.25, therefore the bottom times 0.25. Exactly the same bit of maths is going on there. So again, in your calculator, you will type in, so I've just lost my calculator for a second. Okay, you would type in 13 times 0.25. Now, I haven't been doing this on here to save time, but you should really type everything into your calculator twice that you do, so you know you've not pressed the wrong button. So every time you use your calculator, you need to really type it in twice to be sure you haven't made a daft mistake. So there's your final answer. You've done a conversion and you've used scale. Okay, watch out for percentage questions. If the percentage question is quite early on and it says an item is increased by 5%, what is the new price? Then that is find the percentage and add it on. They say there's discount of such an amount from this, 20% taken off, then you find it, take it off, and you may need to tell them what the discount is and how much has been taken off. This one, though, says after a 5% reduction, boots, they're priced at £28.50 after a reduction. The clue here is saying what was the original price. It might say what was the starting price, what was the price before it was reduced. And the original always equals 100%. Keep that in mind. The original, the starting price is always 100%. So they want you to tell them what it started out at. So they've had a 5% reduction. So their end price is actually 5% less than the 100%. So it's actually that 28.50 is 95% of the original. So 95% equals £28.50. Now, there are several ways of doing this. If you've got a better way of doing it, then that's fine, but as long as it works, okay? You cannot just take off or add on 5% here. It will not work, okay? Not one of those sorts of questions. So what you can do here is the best way really to think about this is to think, well, let's work out 1% then. Again, there are other ways you might spot and come down to 5% if you can spot that, but 90 down to 1% is going to be dividing by 95, okay? To go from 1 to any number, I times by the number. To get from a number back to 1, I divide by that number. Same to both sides, so you can have a very small amount here, but we're not finished yet. So, get our calculator. Okay, we've got £28.50 divide by 95 is going to be 0.3. Be very careful in a money question. You've got 0.3, that is pounds, and 0.30, always 2 decimal places, okay, for money questions. You could have put 30p there, but your calculator gave you 0.3, so we're going to need money pounds in a minute, so let's leave it there. We, though, want the original amount, so we need to find 100%. To go from 1 to 100, I times by 100. So therefore, I times this by 100, okay? And that is going to be £30. Don't guess it, use a calculator if you need to. Now, I can do a check here, a final check. If I have £30 and I take 5% off, I must end up at £28.50. So 10%, just a quick bit of check here, 10% of £30, okay, equals £3. Therefore, 5%, and again, you could use a calculator for this, just doing a quick check to show you, of £30 is £1.50. And if I do £30, take away £1.50, I have indeed got my £28.50. So I know that's worked, okay? So you cannot just do the adding on 5% or taking off 5%. You've got to work with this reverse percentage where they are after the original amount. So my final answer is that £30. So they're asking for the original or the starting price. You've got to do a reverse percentage. Okay. Now this might look a bit confusing. 1 to n, gosh, what's going on there? It's more algebra. It's basically saying they want the first part of this ratio to be a 1. And the second part will just be whatever it is. Now here, sneaky, they've got millimeters and centimeters. Always look out, do you need to do a conversion? And that is, again, another conversion mark ready to be picked up if they give it to you in this format. So we've got 100 millimeters, 60 centimeters to get from centimeters into millimeters. I times by 10 because there are 10 millimeters in a centimeter. So I get 600 millimeters. So I've now got 100 millimeters to 600 millimeters. Now, I must have a 1. So I'm coming down to 1 here, 1 to something. So to get from 100 back to 1, it's that any number back to 1, divide by whatever number you've got there. 100 divided by 100 is going to be 1. Therefore, I must do the same this side, divide by 100, and I have got 6. So 1 to 6 is the 1 to n ratio for this example. Do not be put off if you've got a decimal this side, okay? A 1 to 1, a whole number here. A bit like currency, it maybe is £1 to $1.25. It's a decimal. Do not panic if that ends up as a decimal. But make sure you've got your conversion done. They're the same units of measure. You've converted correctly. You've done the same thing to both sides. Okay, so this is a basic proportion one. A bit like we do recipe questions. A bit like the reverse percentage one, really, as well. I'm going to line it up. Okay, pencils and money. 8 pencils cost £4. Some of you might spot that you could just add 4 pencils on. So you find the price of 4 pencils, add it on, you get 12. Absolutely perfect. But let's show you a way that's going to work for any numbers because you could get some dodgy numbers here. If we find out how much 1 pencil costs, so 8 to 1, any number to 1, divide by that number. We must do the same to both sides. See, these links are coming out in so many questions here. It is just a brilliant, clear method. 4 divided by 8. Don't guess it. Do it on your calculator if you need to. Okay. It's going to be a half. It's going to be 50p, or it's going to be, half a pound. If you do put it into 50p, make sure you put it back afterwards into pounds. We want 12 though. Okay. So 1 to 12, we're going to times by 12. So 50p times by 12. Okay, just to show you if you had converted it to 50p. So if you put 50p in and you times it by 12, be very careful. 600, if you put 600 as your answer there, does that make sense? 600 pounds. Be very careful, either put 600 pence as your answer, or at the end, turn it back into pounds by dividing by 100. Okay, so be very careful if you do change it into pence, either put your final answer as pence. Okay, it does sound a bit daft to say 600 pence, isn't it? It sounds a bit daft. You wouldn't have that as a price in a shop. £6 is much better. And you would usually put it back in the format they gave it to you anyway, like the £4. Okay, this just relies on a bit of general knowledge. And the knowledge here is that one day, okay, as a whole day and night. When we talk about a day, it means a day and night. So a whole Tuesday or a whole Saturday is 24 hours. Okay, so you've got 2 days. It's going to be double that. So 48 hours. Let's hope we get a nice question like that to start us off. Okay. So this is another area that is lots of mistakes get made. There is a slide in the big revision PowerPoint coming out that has got the rules of bearings. And the first rule is that bearings are always measured from north. And hopefully they will give you this as a drawing, or at least 2 towns marked on a bit of paper, the paper for you, okay? Now, they also get measured from so your protractor would be on there, but here they're giving you this to calculate. On the paper, it probably will say not drawn to scale. It might say that. It might say calculate. It might actually want you to measure it properly with a protractor. So if you do that, north is always 0 degrees. Make sure 0 degrees is north. Your protractor is sort of, this way around, and your 0 degrees facing that. And you always measure clockwise. And what you should also do, if I can do this here. So if I can draw a straight line here, because you need to be accurate here, okay? You should join up, oops, the 2 points. Oh, that didn't work. Okay, rid of that. I wanted to draw a straight line. See if I can get a straight line on here. Okay, hopefully. Nope, okay. So you get the idea, you draw a straight line, okay, between your two points with a ruler, okay? So use a ruler. Mine isn't working on the screen now. There's the straight line there. I don't know why it's come over there. Never mind. Okay, so we've got our straight line between the 2 points. On there, they've given us from X. Now I'm going to tell you this one here is X. They should give you these towns written on your screen. So I can tell you that the bearing of 267 from X is actually this angle all around here. Okay, it's gone from north, it goes clockwise. That is the bearing of 267 that they've given you. Just label it there. 267. Okay, so they want to know what is the bearing of X from Y. Means we're starting on the Y north line and we're going round towards X. So that means they want us to tell them what this angle here is. That angle there, joining between the Y north line and the X direction of travel. So if we haven't got an accurate drawing, we have to calculate it. And if we're going to calculate it, we can use our knowledge that these two north lines are parallel. Okay, they're parallel lines. This now becomes an angle on parallel lines question. We should know that angles around a point, so this green angle and this little pink angle here, those two will equal 360 degrees. So to find this pink one here, if I take away the 267, okay, remember it is calculator exam, 360, take away the 267, type it in twice very carefully, 93 degrees. So that little pink bit there is 93 degrees. That is not our final answer. I'm going to label it on here. Everything you can label in a diagram will also help pick up some marks. I want to find this one. So now I can use the rule that between these two parallel lines and my straight line that would have been drawn with the ruler, those two angles are co-interior. Okay, it's one way of calling them co-interior. They equal 180 degrees. So there's usually a couple of special angles. You've got 360, you've got 180. Those numbers keep repeating in angle questions. So what I need to do now is have the 180 co-interior, take away the 93, that pink angle that I don't want, and to find this one, the 180, take away the 93, 87 degrees. So this angle here is 87 degrees. Now, that is not finished yet because the last rule of bearings is it must be 3 digits long. You would lose a mark at that stage. So the answer is 087 degrees. You've got to have it as 3 digits. There is another way of doing this. If you know it, brilliant. Still using angles on parallel lines. You can extend the north-south line and do it that way with 180 and something else. But this is a solid way of doing it. Okay, but remember that leading zero for 2-digit angles. Okay, angles in a triangle. This one's quite a simple example, really. But angles in a triangle. So in a triangle, equal 180 degrees. If you've got to give reasons, then you need to have these words, and really I've cheated there. You should have the word angles, okay, in a triangle equal 180 degrees. That's a reason that would get you a mark. But here they've just asked you to find X. Now you've got 180. That little corner here indicates it's a right angle, so that's 90. And you're taking away 45 as well. So whatever you're left with is the value of X. So 180, take away the 90, take away 45 is 45. Now, those of you who saw it might just say, well, I know that 2 45s is 90, so that must be 45, okay? Other thing to look out for in triangle questions, if they've put a little dash there and a dash there, they might give you nothing up here. That means this side is the same, this side is the same. These angles, basically the base of an isosceles, because they are the base angles of this isosceles, must be equal. So that 90 that's left over from our triangle must be split and be 45 each. So that could be something else they do. It's not even give you that angle. They might give you 2 markers like this. Remember, you can always turn your paper around. That means these are the base angles that go with the equal sides. Just watch out for sneaky things like that. Now this area of trapezium, trapezium can be drawn like this. A trapezium just has one pair of parallel sides, okay? Doesn't have to have a right angle. The only special property is it's got 4 sides and it's got one pair that have to be parallel. So you might see a trapezium drawn a little bit like this. Excuse the sketch, okay? You might see it like that. And those two are the parallel sides. You might see it drawn up this way with or without a right angle like that. Okay, and therefore those two are your parallels. In this case, if it's turned around, please, 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 remember you can turn your page around, all right? But this is your A, this is your B, and this is your height. The height has fallen down on the floor now, but if you turn it around, it's still a height, okay? The height has to be at right angles. And here you'll see H, okay? is their perpendicular. So separation. This is actually a snip from the formula sheet that will appear in your paper. The perpendicular separation just means the height at perpendicular. So here, if you've got one of this sort of thing, you'd have to drop your height in at right angles to your base. Now watch out here. This could be a bit of hidden Pythagoras. If you've not got a height, they've given you this amount here, and they've given you this bit here. You might need to find your height by using Pythagoras. So be really careful that you spot the hidden Pythagoras. It would have to be, the height of that triangle there. And that is at right angles. So that would be your height. Okay, just something to watch out for. But let's use the example we've got here. We've got A and B, and C is your height in this case. Okay, this is your height, is your C. Okay, it's giving you what C is. They might write on the diagram for you. So just put them into this formula. We don't really even need to know why it works, but basically you're finding the average of these two lengths. So add a bit onto here, take a bit off of A, and join it up. You've then got a rectangle, and that's what we're doing basically. So we're averaging those A and Bs. So it can also be written like this. You could have A plus B over 2 and then times height, not to be mistaken with the area of a triangle. Okay, the area of a triangle, okay, the area of a triangle is A times B, okay, sorry, base times height. Let's use the right terminology. It's very, very, very similar, okay, to trapezium. So triangle would be base times height over 2. Okay, so that is separate and not to be confused with the trapezium one. So they'll give you this trapezium formula. They're not going to give you the triangle area. Okay, just remember that one. So put our numbers in. So A is 10.6 and B is 14.2. And we're going to divide by 2 and then we're going to times by H. Okay. So let's do that on our calculator. Be very careful you've typed it in correctly. So we've got a fraction here. It is a fraction, isn't it, written like that? Or you can do it in this method they've given you in the formula, absolutely fine with the bracket. But I'm going to do 10.6 plus 14.2, cursor down. You should be writing down on your page everything you type in your calculator. Times by, now the H is 3.8, okay? SD button, so 47.12, let's just write that down. 47.12, and one thing I didn't write in here, I should have done, is I should write times 3.8 there, okay? So 47.12, it's centimeters, so it will be centimeters squared. That is done. Let me just show you that in the way that they've given up here in their formula. So a half, okay, 10.6 plus 14.2, okay, times 3.8. It's stuck to the bracket, so it times by the bracket. Just put that in our calculator and show that it also works. So we've got a half. So you could do your half or you could write in 0.5. It's up to you. It's stuck to the bracket, so I'm going to put a times in there. 10.6 plus 14.2. Always checking as I go that I am typing it incorrectly. And I can cursor back to check as well, like that, to see it's all in. Okay, equals SD button. There we go, 47.2. So either way works. Be careful, you make sure you put your units of measure at the end because that could be worth a mark if they've not got that on the answer line. Okay, the last question. So actually, before I move on, just to reiterate, the area of a triangle is this, the area of a trapezium is this. You get given this in the exam. You do not get given the area of a triangle one. Just write that on here. Okay, this is the area of triangle. Okay, do not get mistaken, and watch out for maybe hidden Pythagoras there. The last question is Pythagoras. Now, this is what I would call a forward Pythagoras, which means I am using the formula in the way it's given to you in the exam. This is because we're finding the long side here. So if you are finding the long side, then the formula, I must find the ruler, sorry guys. So if you're finding the long side, right, go very slowly. If you're finding the long side, then you're okay to use this, what I would call a forwards formula. If you're finding a short side, you need to rearrange and use a subtraction. It's about the squares off here plus the squares off here will equal the squares off here. Okay, there's a slide in the revision PowerPoint, look up for that. If you're finding a short side, like A or B, then it's the squares off the biggest side, take away the other squared side, gives you the shortest squared side. Okay, so be very careful, if you're finding the longest or a shortest side. So we know we're doing the longest side. We've got the dimensions here, we've got our formula here. You'll get no marks for reproducing that formula, but you should get marks if you substitute in. So let's say 6 squared, so my A length and my B length, and C is always the longest side. Be careful, this triangle could also be flipped round. So the X, the hypotenuse or that diagonal line could look like it's underneath. Just very careful. You've got the longest side, okay, the dimensions. 6 squared plus 7 squared equals, it is C squared. You could call it X squared, it doesn't matter. Right, we've got 36 plus 49 equals C squared. Again, you don't need to chance it. You can use your calculator. Okay, we've got 36 plus 49 equals 85. Write down every single step you do. So 85 equals C squared. That's why I write C squared here, so you don't forget the last step. If you now said that X is 85 centimeters long, that hopefully will ring alarm bells. That is far too long if these two sides are only 6 and 7. How can it possibly be 85 centimeters? So there's a last step to do. As in a previous question, we're going to do the inverse of squaring. Now, the inverse of squaring is to square root. So if we square root on both sides, okay, we get the square root of 85. That loses that power. So square root of 85 equals C. So then one last step on your calculator. Okay, square root button, 85 equals useful, SD. There we go. That's what we really want. We want the actual amount. 9.2195. Again, I would write as much down as possible. 9.2195. 0.2195, and then it's asked for it to 1 decimal place. So we're going to stop there. We're going to look there. That 1 keeps it down at 2. If it had been a 5, 6, 7, 8, or 9, it would round up to a 3. So be very careful on your rounding. There is also a slide on the revision PowerPoint coming out that talks about rounding carefully into significant figures and decimal places. So final answer there, 9.2 centimeters, because I'm finding the longest side. I'm doing a forward Pythagoras. Okay, I hope that's been useful. Again, it doesn't actually cover every single skill you're going to meet in paper 3, but it gives you a good coverage of a lot of the skills, especially the algebra stuff that's being rearranged, and a lot of use of the link. Good luck.